Hello everyone and welcome to the introduction video of MATLAB Simulink environment. Today we are going to take a look at how to implement basic signals such as sinusoidal waveform using Simulink built-in features, and you will see how they look like on the oscilloscope and as well as the spectrum analyzer. First thing that we are going to do is we are going to open MATLAB. This is MATLAB 2016A. After that, we are going to open the Simulink environment by clicking on the Simulink toolbox from the toolbar. So after clicking on the Simulink toolbox, it's going to take a few seconds until it opens the workplace. As we can see here right now, this is Simulink start page. From Simulink start page, we're going to choose Planck model in order to open and start working on the workplace. So after clicking on Planck model, from here on we're gonna work and we're gonna add a sinusoidal DSP signal. So this can be obtained from going to the library browser. From the library browser, we're gonna search for sine wave. We're gonna choose DSP sine wave. We're gonna drag it by left clicking on it and dragging it toward the workplace, letting it go. And now this is the sine waveform generator. Now we're gonna add a scope. By using the same logic, we're gonna drag it toward the workplace. And for the final thing, we're going to add a spectrum analyzer. We're going to left click on it, drag it towards the workplace, and we have our working boxes ready. The next step is that we're going to connect them together. By left clicking on this arrow right here, we have connected the sine wave generator toward the scope. And by clicking on this arrow right here, we're going to connect the spectrum analyzer to the waveform generator as well. Now we can go deep into details of the sine wave generator by double clicking on it, and you can choose some parameters such as amplitude. For example, let's make an amplitude of 2, and as well as the frequency. You can choose any frequency that is suitable for you. Let's pick a smaller one. Let's choose 10 for example. And another parameter is sample time. Here frequency of 10 means that the period is going to be 1 over 10, which means 0.1. so this is the signal frequency. In here, this is sampling time. Sampling time is 1 over sampling frequency, so this 1000 here represents the sampling frequency. In general, the sampling frequency should be at least twice as big as the signal frequency according to Nyquist theorem. So 1000 is bigger than 10, twice 10, so this is a suitable value. The higher it is, the more accuracy it's going to be. So our waveform is ready to be generated. By clicking on the run icon, the Simulink is now running this sine wave signal. Now we have some results. Let's speak about these results. From the scope shows the signal in the time domain. So this means that this sine wave is in the time domain. According to the parameters that we have given to it, it has an amplitude of 2 and a frequency of 10. So this means that the amplitude should be 2 in the scope, and also the period should be 0.1 in the time domain. Let's make sure about these two parameters. So from the scope, we can see here that the amplitude is 2. This is the sine wave form. Let's make sure about the period now. By zooming in, clicking on this zoom icon, let's focus on the range between 1 and 2 seconds. So this should have 10 periods. This can be seen clearly here. This is a start of a period at 1. Let's zoom in more. We can see here that the start of the signal starts here at 1 and it repeats itself at 1.1 right here. So this is what it's called a period. A period has a value of 0.1 according to the frequency 10. So from 1 it repeats itself at 1.1. It starts again. Or you can choose it as a peak to peak. From here, from this peak to this peak, this has a value of 1. Sorry. So from a peak to peak, the period is 0.1 seconds. The spectrum analyzer shows the waveform in the frequency domain. It takes its Fourier transform and then shows us this signal in the frequency domain. So the scope shows us the sine wave in the time domain, and the spectrum analyzer shows us the signal in the frequency domain. According to Fourier transform, the sine wave Fourier transform is 2 pulses depending on the frequency of that signal. So we chose the frequency of 10. So after zooming in, let's zoom in one more time to see the value. We can see here that the value of 10 is represented as the pulse, and also in the negative it's minus 10. So this was a general description of a sine wave and how to implement it and how to see it in the time domain according to the scope, and in the frequency domain according to the spectrum analyzer. After finishing the work in the Simulink environment, we can go to File and then Save As. Let's name it, for example, sine wave. Let's save it to the desktop. After saving it, in Simulink, you can't just double click on a file by itself and then open it. You have to go to Open MATLAB. You have to open MATLAB and then click on Simulink, and from here you can choose Open and then choose the file that you would like to open. For desktop, sine wave, open, and we have the work that have been saved by us. Another quick way is just closing it from the MATLAB, open Simulink. We can see here the recent files that you have saved or worked in. So all you have to do is double click on sine wave and you have obtained the same work that you have done. This was the end of the first tutorial. Thank you for listening. I hope that you enjoyed it. See you in other tutorials as well. Good luck.